Hi, everyone. Welcome to another episode of the Open Rewrite Community Office Hours. As always, I'm Tim de Beek, and here's my colleague, Sam Snyder.
Hello.
We're going to take you through what is new this week in Open Rewrite and Modern. So, it's been an interesting week. I'll first take you through some of the new things that we found. And first off, I can share my screen a bit. And you can see that we are up to 2,300 recipes available through the Modern platform. Again. Now, I already showed you last week that we added some 300 recipes that week and the week before. And then we added another 100 this week, which is mostly due to adding support for the Quarkus recipes that friends of ours at the Quarkus project have developed over the years. And you can now also run them through the Modern platform. So you might know they have a CLI that allows you to run recipes in that way, but that's only one project at a time. Whereas if you want to run recipes, perhaps against the entire Quarkus open source organization, then we have some 127 recipes here, 127 repositories here that you can run these migration recipes against. So it's really, really neat stuff to be able to take these existing recipes, which are valid and working well, and run them just at scale through Modern. So go explore that. And apart from that, we also showed you that we're able to run recipes from support, but I don't think we've shown you any kind of concrete results yet. And one that we've been playing around with the past week is this first one of the couple hundred recipes that we have here, which optimizes your usage of the Java time APIs. So this one, you can see there's a lot of cases where you can do things a little more idiomatic when you're using these timed APIs. And what we like is just to run this against an organization and find any hits that you could find there. So in this case, if I take all of these rules and I just run them against our default organization, you'll see that we'll queue up some jobs and start to run these recipes. And quite quickly, you see the first result pop up. And in this case, you can see for ND bench, we are changing the way that we create a zone date time from a regular date. You probably have seen some variation of this as folks have been trying to struggle through, like, what is this new API? How do I use it best? And what these recipes then do is, well, they know what you want to achieve, and they do it in the most straightforward way. They have a lot of recipes that are just a simple before situation and then replaced with this answer template. And it's just really nice to see what this does at scale, where you don't have to find these instances. We'll just find them for you, fix them for you, and pull up a pull request. And as always, you can just commit this directly if it's something you own, or open a pull request. And it's a really neat way of running these recipes in a way that just wasn't possible before. So really neat stuff. And if you run it against maybe a larger set of repositories, you'll find more hits. In this case, there's another two cases in Mantis. We're also doing similar replacements, constructing a duration just with an easier way to do that. And it's just, I quite like this. We've even had Rick from the Error-Prone Support project contribute back to Open Rewrite, running these recipes, improving things on our end. And that's a really neat way to go about it. And we'll have him on in 2 weeks where we can go in depth a bit more on all of this you can do in this way, and see what else is out there. But this is just like I said, this is one of their rules, and we have some 300 plus. So go explore. Let us know what you find and what you think works well. And if you have any contributions back to Open Rewrite, we'd love to hear. So go see what's out there. And then another thing that's new is it popped up on our radar, where if you are using the early access versions of IntelliJ, then they have built-in support for Open Rewrite, which is something is just really neat, where you can take a project that contains recipes, which you can then define in your regular rewrite YAML file, and then you can run them directly from your IDE. And I'll try to have a better demo for you next week, because right now it's early access and my early access instance doesn't want to start. But I do have a very short video that I can try to switch to, so you have a bit of a preview. And hit the switch and black window. And what you see here is just a small YAML file that you might know already. But you do notice that it's got an Open Rewrite logo on the left-hand side. And the very keen eye will notice that there is a small play button that has appeared next to this recipe. And what you can now do is just run it by pressing the play button in your IDE. And then suddenly it will start to make these changes to your project. So that's, I think, really neat to see what the folks there are doing. But of course, it is open access. I've tried it out on some of my own projects. I probably need to report 1 or 2 bugs. But I'm really looking forward to what this will do in a month or so when the new version comes out. And with this small example, you'll see that we are actually defining a recipe and we're running it, and we'll actually see the changes in just a couple of seconds as well. Waiting for them to show up.
It'll be really nice to have this, as I almost never hand edit a recipe YAML inside of one of our projects. My go-to way to do that is the recipe builder inside the Modern app tenant, free for all open source GitHub users. As the recipe builder there has traditionally been a more convenient way to set up a valid YAML without having to potentially get any spacing wrong or have to constantly look up the names of the configuration options on the recipes being added or any of that kind of stuff. So it'll be really nice though to have this functionality in the IDE for when we're actually editing existing recipe YAML by hand. So I'm looking forward to this.
Yeah, absolutely. And they added support for discovery and some validation rules that we usually apply. So it's just really convenient to have it in your IDE as well. And then of course you can compose them in the platform and run them at scale and try them out in that way. But this it's just a really neat addition as well. But we'll look in more detail once it's out of early access, or at the very least stable enough to launch my IDE. So all good. So then I'll switch back to my regular screen. So if you want to try that, it's in the early access version. It's a 1 gig download, but then you can see how it works. And then some other things we've been working through, like last week you saw us build some more example recipes. Last week we did a scanning recipe. And what we've done with our rewrite recipe starter, which is available on GitHub, Modern Inc/rewrite recipe starter, is that we've added all these reference implementations there with some links to the tests, some links to the docs, such that it should now be easier to find something that looks like something you want to do and modify it and run the tests and have that all working.
Speaking of enhancements made to Rewrite Recipe Starter, I also added a Maven pom.xml to it. As I know some of you good people out there prefer the Maven build tool to the Gradle build tool. So previously in this repository, we only had Gradle build files. But if you are looking to use Maven to build a recipe module, well, here you go. Here's a POM that sets up all of the appropriate configuration to apply the Lombok annotation processor, our annotation processor, which is necessary if you want to write the refaster style recipes like those Tim was talking about earlier that do the time manipulations. And there is one of the examples Tim has included in here is of one of those refaster style recipes. So so take a look if you're looking to get into recipe authoring, and if you're here watching this, I kind of assume you are. take a look at this repository. There's a lot more in there than there was last week.
Yep, absolutely. So should be easy to get started with, no matter what your build tool of reference is. And yeah, you have all these recipes that already work and that you can expand and manipulate as you see fit. So that's it in terms of development. And then what's also very neat is that our colleague Justine has written another blog on maybe more of the AI side of the Modern company, where we took a challenge that we had at the customers of ours, and used a mix of the Open Rewrite LSTs and AI to fix that for them. Right? The problem they had was quite amusing, where they have a lot of their code in French. They have a lot of their code comments in French. But over the years, some of the files that they were using had been misencoded in various different ways. And that then resulted in having these question marks pop up in your code comments. And that is very annoying if you want to read your comments. So what we've done on our end is we've developed a recipe that specifically visits any kind of Java docs or comments, and then detects if they are in English or French, and if they are in French, and if they contain these misencoded characters, then we actually call out to a AI that is deployed as a sidecar to ask, like, given this context, what do you think the missing characters should have been to make this valid French again? And it's really working very well. And what it then allows the customer to do is that they're now suddenly able to generate their Java docs again, because those Java docs, they choked on these misencoded characters. So it's might seem like a small improvement, and if you only look at a single file, but what it enables you to do at scale is just have that documentation generated again and accessible for folks to use for all these libraries and frameworks. So really neat work.
A really good use case for automation, because it's one of those things that would just be so massively tedious for a human to track down and fix that. It isn't hard, but you'd have to find, across 1,000 repositories, find the 10,000 files that collectively have the 100,000 comments that with the one misencoded character, go through, find that. It's not always the same. Like the same character that is misencoded. Any character with diacritics or anything like that is potentially one that has ended up misencoded over time. So yeah, it's one of those areas where automation is going to get the job done, and a human with the same assignment would never get it done. They'd pull out their hair before ever finishing.
Yeah, absolutely. So yeah, really neat. And go read it up. I've shared the link in the chat such that you can have a look there as well. And then one other thing which was neat over the past week is that a friend of ours, Jonathan Lightshoe, has been also streaming on Open Rewrite recipe development. And one of the improvements that he's done is make it easier to find assignments to constants. And that has a wide range of uses. And one of the uses you can see in a unit test here, and if I zoom in a bit, you can see that this is a recipe that we have to phase out a feature flag. Now, this one in particular is for using the Launch Darkly API. You can I'll select the before template here. And what you see here is that we are calling their client to ask if this particular feature flag is enabled or not, and then call the left-hand side or the right-hand side of this recipe. Previously, we weren't able to handle this case very well, where the feature flag is actually a constant defined elsewhere. But now with this improvement, we're actually able to find this case. And if you then choose to permanently enable or disable this feature flag, then we're able to minimize all of the above into just choosing, in this case, the on side of this recipe, where we take the correct side of the conditional and remove everything else. So it's a really nice enabler. And if you want to look how that works, you can look into Rewrite Launch Darkly. And there you can see that the commit that was made is really, it's a nice simplification as well, where you just, in this case, take all of this code and replace it with this constant fold. And that's, yeah, very nice to see what folks in the community are doing with just what the tools that we provide and that they help shape and use in this way. So that's a quick roundup of what is new in the past week. And then for this week, we were gonna dive further into what is interesting for if you want to do your own recipe development. So I'm just going to take you through the topics of search recipes and data tables, and we'll have more to share there.
Yeah, I don't know if Jonathan let you if he recorded a video of that live stream anywhere, maybe to a YouTube channel or something. If he did, we should try to find it and post the link so people can appreciate it. Yeah. In the meantime, I will go ahead and get started talking about search results and data tables. Let's see. Oh, hello, Kat. My co-presenter Nazgul is here to get a whisker in on the subject. He has a lot to say about search recipes. Usually, what he says is meow or some variation thereof. Let's see where to start. So we've talked a lot here and elsewhere about recipes that make transformations to code, but often you're just trying to ask a question about your code and get that answered. And we have a couple more data collection oriented mechanisms that recipe authors and users should be aware of for asking and answering questions about your code. So let's first I'll show off a search recipe, say, and then we'll look at how it's implemented, and then we'll kind of do something similar for a recipe that produces a data table. So here I've pulled up the Medern Sass that we all know and love. Let's do a search. So we have a number of search recipes that are already in here. Apparently, we need to search for the search recipes first. I wonder if our AI recipe search service is being a little slow at the moment.
I fear it is. Yes, you can temporarily disable it on.
Yeah, maybe I'll switch back to the Lucene-based search. Wait, that is in. Yeah, let's turn off AI-assisted search. Yeah, there we go. So one of the most basic kind of things you might want to do with a search recipe is find usages of a particular type. If you are someone who maintains a library that other people use, you might want to see how they use it. You might want to look up where usages of a particular class are. So let's actually. So let's say I was wanting to learn more about the data tables feature in Open Rewrite, or figure out where people are using the data tables feature in Open Rewrite. I could use a search recipe to do that, and I'll set this to search through our org and kick that off, give that a run. And so a search recipe is substantially the same as a regular recipe that makes an edit, except instead of changing code, it just adds what we call a marker, which within the Sass is rendered as this cute little magnifying glass. And that doesn't result in a code change. There's nothing to commit. The commit button is indeed grayed out. It just marks a particular part of a particular LST as interesting. And so, for example, here, I have searched for everything that implements this type data table. By setting check for assignability true. That's going to include subtypes of the data table type. And so now, if I am looking to learn about how this particular feature is used throughout our code base, it's just one click to go and find all of these examples of its usage. And so that can be as a library author, a great way to answer a question like, I want to deprecate this method, or I want to add some new functionality. How is my feature currently being used by my users? And if you're actually publishing a library that's used in open source, actually coming to app.modern.io as is a great place to search through, you know, some 35,000 projects that are open source on GitHub. But even if you are, you know, doing something closed source or working with just the Open Rewrite Gradle plugin or Maven plugin, you can still use a search recipe to do that kind of search locally, and you would just get, you know, a diff file, a patch file that you could look in to see exactly what the search results were. So yeah, search recipes very handy for that kind of thing. So what does it look like if we actually go and look at the source code for that find types recipe? Got that open here, and there's some logic in here of going through, you know, the stuff particular to this recipe, like visiting an identifier and grabbing off its type information, checking whether the type matches the one we're looking for, and if it does, here's kind of the crucial method that makes a search recipe a search recipe. You know, rather than changing anything about this identifier, we just wrap it in a search result, which if we look under the hood at this guy, search result.found more or less just adds a marker of type search result to that element. And markers, if you don't remember or seeing this concept for the first time, are metadata that is attached to an LST. Some markers come pre-populated by the framework, things like what Java version is in use, what build tool produced the file, that kind of handy stuff. And then there are markers that can be added by recipes. Most of the time, if a recipe is adding a marker, it's going to be a search result. But it may also be an implementation detail of that recipe, such as to, I don't know, keep track of some piece of information from one visit to a next. But that use case is less common. So sometimes search results are empty and there's nothing in particular to say about a given search result. But sometimes you may wish to optionally provide a description. So I don't know, we can find some usages of this method. Yeah, so like over here in our find colliding source files, which is a recipe for finding multiple multiple different classes that have the same fully qualified name, which is usually not something you'll have happen within a single project, but in a multi-project build or in a multi-repository scenario, it is possible and subtly problematic to have multiple source files with the same fully qualified name. This guy includes an optional description in the search result, and when that happens, that's just displayed in the UI or in the diff as part of a comment next to the LST item that has been noted as the search result. Yeah, and so search results are well and good when you are trying to say, I know I am looking for instances of a particular thing and want to see those instances in the context of the code, where they appear. But that isn't always not every question is answered most conducively with that kind of result. So another feature that Modern provides, and this is actually something that the Open Rewrite Gradle plugin and Open Rewrite Maven plugin do not produce, as we typically see this is valuable most in a multi-repository context where those tools are inapplicable, is a data table. A data table is a collection of tabular data defined by a recipe that is collected by that recipe and placed into essentially an Excel spreadsheet or a comma-separated value file, or soon a JSON blob, and it's just any information that you might wish to collect. So let's go over to Rewrite Recipe Starter, and there's actually already an example in here of such a recipe, but I've deleted it so that we can kind of live code it from scratch for you guys to see how this works. Although before I start implementing it, I should probably show off some recipe that produces a data table. And I should have thought about this in advance, what data table I was going to demonstrate, but I didn't. So let's see. maybe we'll do one from rewrite Java dependencies, and I'll just go back to, yeah, we could go back to maybe dependency vulnerability check. That's a good one. So if I were to go run, find and fix, I had to go run or find and fix vulnerable dependencies. This recipe is actually a great illustration of search results and data tables and just ways we can help with the remediation of security vulnerabilities. So let's just go give this guy a run. I'll say add markers true. And so we'll go run this, and this recipe, looks through all of the dependencies that it finds in a given project, and compares those to the GitHub Security Advisory database, which includes the NIST database, which the NIST is the source of all of those lovely CVE numbers, enumerating all of the critical vulnerabilities that have been found by diligent security researchers throughout the world. And so within a Maven POM or a build.gradle, this will try to go mark, hey, this project is bringing in a version of Spring Boot starter validation that transitively depends on Logback Classic, 1.4.11, which is known to this vulnerability database to be affected by this CVE. So you can see the search results in the recipe diff itself, highlighting exactly which dependencies are bringing in a transitive dependency that is known to be problematic in at least some circumstances. And it can also, I don't know if we have any examples here, but it can also actually update some dependency versions, at least currently when it is a direct dependency version, it will try to make a code change as well, just naturally move you to that latest version. But, already just looking through here, looking through this, there's several hundred results. And if you wanted not to zoom in on each one of those and see where the dependency is coming in that particular context, but zoom out just a little bit to get a more holistic sense of where you stood on vulnerabilities, well, this recipe also produces a data table. And so if I go over to the data tables tab, I can go download that. And what we get is a vulnerability report Excel file, which shows all of the data that was found by running the recipe. And like all data tables will note the repository origin, path, and branch, source control type, and a link back to the repository. So these first 5 columns are common on every data table that Open Rewrite produces. And then all the columns thereafter are defined by the recipe itself. And so in this case, in the case of vulnerabilities and transitive dependencies, we note the CVE number, the version of the dependency brought in that CVE is associated with, and if it is known, a version of that dependency that has the fix. So you can see how this kind of data table would be quite handy for getting an at a glance view of your risk or exposure to the vulnerabilities throughout your transitive dependency, your full transitive dependency closure. So how does one produce a data table like this? Well, again, it is kind of it's not the open source build plugins won't produce this, but it won't produce data tables. But if you run through the Medern app or through the Medern CLI, you can get these data tables produced. So how does one go about, we saw how to implement a search recipe. How does one implement a data table recipe? And, much like searches, there is no different superclass. There is no distinction in the type system between a search recipe, a refactoring recipe, a data table recipe. So understand when I use these terms, I'm just speaking informally about the behavior of the recipe rather than about a rigid definition. As we saw with find and fix vulnerable dependencies, a single recipe can add search results, suggest changes, and produce data tables. So let's go implement a search result. Actually, how much time do we have left? Do we have time to implement this search result recipe today? Maybe I will just show off briefly the one that we already have in the rewrite recipe starter, since we added one there recently. So if we go over to this rewrite recipe starter repository, there is an example of a recipe named class hierarchy, which produces a data table. And if we look at this guy, we see that it declares a field, which kind of by a loose convention, we tend to include the name report in that field. And it's marked transient not because there's actually any multi-threading going on here and we have to worry about some other thread changing the value here, but that prevents, just that marker kind of calls it out as a temporary sort of field, so that it won't be included in the constructors or getters and setters generated by Lombok when we use these value annotations. So yeah, the transient is optional, but you could also just exclude it from the constructors that are being generated. And so then inside the recipe, and this particular guy produces a data table showing inheritance relationships between classes. So what this does is, I don't know why override is being highlighted. I wasn't interested in that. I probably just clicked on it. So within this recipe, what it is trying to do is produce a data table showing inheritance relationships between classes. So whenever a class extends another class or implements an interface defined in another class, this adds it to a data table so that you can get a picture of your class hierarchy and go analyze that and see what the relationships between the classes in your code base are and the relationships between your classes and the libraries and platforms that you use. So this guy goes and visits Java class declarations and it grabs the type information off of them, and then it calls this, report is the name of our data table field, and it calls this insert row method, which accepts the execution context, which under the hood is actually where data table information is stored while the data table is being collected during visiting, and a data table defined row class, which contains the information that is to be inserted in here, which in this case is the fully qualified name of the type that's being visited, whether it is extending or implementing the class that is being noted here, and the fully qualified name of the class that it is extending or implementing. And so if we go and look at, I said that the recipe defines the data table, defines the schema of the data table aside from those 5 common columns that they all have. This is kind of what that looks like. You have a class which extends data table and fills in the type parameter with the name, or fills in the type parameter with its row type, a type that defines what each of the columns are going to be. And much like you would define a recipe, use our option annotation to define the options of a recipe. In a data table, use the column annotation to provide metadata about what each of these fields mean. And by convention, we tend to put the data tables inside of a package that has table in the name. But yeah, you can see pretty straightforward here. It's up to you as the author of the recipe to decide what these columns are, and then in the recipe itself to populate them. And of course, no recipe authoring tutorial would be complete without a discussion of how you test it. So if you were to go look at this test, you'll see that this recipe doesn't make any changes to source files, so it doesn't assert that the recipe is going to change any particular class declaration into anything else. Instead, in this optional first parameter to the rewrite run function, you can call spec.datatable and say, hey, this recipe is expected to produce a data table that has these type of rows, and note this is the type of the row, not the type of the data table itself, because that ends up being the more important thing. And then you get the rows of that type passed into the lambda provided as a second parameter here, and you can make assertions that the that the rows in that data table contain the data you expect them to contain. Yeah, and like most things, we like to use assert.j assertions for that. Contains exactly is often a very convenient way of asserting that a collection has exactly the contents you expect it to have. So you see in this case with two sources A and B, which extends A, we would expect to see an entry in the table that A extends Java Lang object and B extends A. And so you can see how a data table with that information would allow you to build a visualization or other analysis that would show you the full kind of class hierarchy of all of the classes in your code. Although I might say that as a practical matter, if you wanted to use this recipe or something like it, I would probably filter out the Java Lang object superclass ones because that's ubiquitous and not very interesting. So that would be a lot of noise. But that's just the fun world of data analysis once you get in there. Yeah, so I think that is a reasonable intro to data tables and to search recipes. So I'm going to stop sharing. And yeah, and feel free to let us know if you have questions about either of these subjects in the Open Rewrite community Slack.
Yeah, so I've been sharing some links in the right hand side, such that if you want to read more about this, we have a short video you can watch as well, and you can follow it that way. And of course, data tables are a very nice step up to what you can then do next, which is visualizations, which we'll likely explore in a follow-up episode, where you can take that Excel file and produce nice charts, or maybe produce that hierarchy that you saw in a way that more easily conveys the message that you want to send with that data. So you can already explore that in this way. We'll probably dive into that at some point as well. And then that is probably where we're going to end it for this week. Next week, we're going to look at a subject that is very close to my heart, which is automating your code reviews with these recipes that we've been building over the last couple of weeks. It's just something that is a big part of my work, where I review community contributions. And I've written myself some recipes to help me do that more easily. And we're going to explore that next week. And then, with that, I think we can close things off for today. And thanks, Sam, for sharing again. And then thank you all for attending, and see you next week.
Cheers. Yeah, thanks a lot, everyone. Cheers.